This is Jacob's Algebra, Chapter 12, Lesson 3, Square Roots of Quotients. Okay, you may remember when we covered exponent rules that x over y to the nth power is the same as x to the nth power divided by y to the nth power. Well, that means that when our power is 1/2, which is the square root, x over y to the 1/2, which is the square root of x over y, is the same as x to the 1/2 over y to the 1/2, which means the square root of x over y is equal to the square root of x divided by the square root of y. Now, there is a rule that you're not allowed to leave a radical, which is anything with a root, in the denominator of a fraction, and you're also not allowed to have a fraction in the denominator of a radical. So, you're not allowed to have a fraction inside of a radical. Obviously, if there's a denominator, there's a fraction there. So, to get rid of this square root y in the denominator, what we have to do is multiply by square root y over square root y, which is the same as multiplying by 1. And so what we end up with is square root of xy in the numerator, and then just over y in the denominator, because square root y times square root y is just y. So if we have something like the square root of 3/7, that's the same as the square root of 3 divided by the square root of 7. To get the square root of 7 out of the denominator, we need to multiply by square root 7 over square root 7, and that gives us square root 21 over 7. Now, just to show you something else that you could end up with, you could end up with something like square root 3 over 8, which is the same as square root 3 over square root 8. Now, you don't have to multiply by square root 8 to get rid of this square root 8 in your denominator. You just have to multiply by something that will make your 8 a square number. If you multiply the 8 by 2, 8 times 2 is 16. So you could multiply this by square root 2 over square root 2. And that will give us square root 6 in the numerator and square root 16 in the denominator, which is square root 6 over 4. Now you could, of course, actually do square root 8 there, and in that case we would have square root 3 over square root 8 times square root 8 over square root 8, and then we get square root 24 over 8, but 24 has a square factor. So we could rewrite 24 as 4 times 6 over 8. We can pull the 4 out. That makes 2 root 6 over 8, and then that simplifies to square root 6 over 4. So if you want to avoid having to simplify, then you want to multiply the denominator of your fraction by the smallest number that will make it a square, not necessarily by itself. Okay, so let's move on and start working some example problems. We're going to look first at number 4, which is just like number 11 that I assigned for homework. The instructions say write fractions whose denominators are squares equivalent to the following. Okay, what it means here, we have the fraction 1/5. We need to write an equivalent fraction that has a square in the denominator. So what's the smallest number I can multiply 5 by to get a square number? Well, if I multiply it by 5, I will get 25. So I have to multiply our numerator by 5, and that is 5/25. Now, it does not say to write the smallest denominator fraction that you can write this way. So if you wanted to multiply by a bigger number, you could, so long as it still made a square in the denominator. So part C, we have 11/18. Now, I have two choices here. Well, I have more than two. I can multiply this by 2 over 2, and that will give me 22/36, which has a square in the denominator. Or I could take my 11/18 and I could multiply it by 18 over 18, which will give me 198 over whatever 18 squared is. Let me look that up. 18 squared, 324. So over 324. That's a really huge fraction, but it doesn't say that we have to simplify anything, so that's fine. But usually, because of the later math that you have to do, it's best to multiply by the smallest number you can that will still make a square number. So let's look at part D, x over 6. We can multiply that by 6 over 6 to get 6x over 36. And then we have part F, which is 5 over 8x, 8x. Okay, to make the 8 a square number, I need to multiply by 2. That's supposed to be a times. To make the x a square number, I need to multiply by x. So that's going to be times 2x over 2x. And we have 10x over 16x squared. Okay, so that was number 4, which is just like number 11 that was assigned for homework. Now let's look at, it's not going to a new page yet. Let's look at problem number 5. Number 5 says, what number should replace the shaded area in each of the following equations to make it true? So for part A, we have the square root of 3/16, and it says that is equal to the square root of 3 over something. What is it over? Well, we have our square root 3. We can still see that here, but we don't see our square root 16 in the denominator. What is the square root of 16? That is 4. So 4 is our missing number here. Let's look now at part B. We have the square root of 4/25, and that is equal to blank. Well, remember, we can do the square root of each part of the fraction separately. Square root of 4 is 2, square root of 25 is 5, so our answer is 2/5. Let's look at part C. Part C says the square root of 2/7 is equal to the square root of 14 over something. Okay, so how could we have gotten a square root of 14? We must have multiplied by 7 to get a 14 in the numerator, which means we must have multiplied by 7 in the denominator as well. If our denominator is the square root of 7 times 7, the square root of 7 times 7 is just 7. So this is the square root of 14 over 7. Okay, so let's take a look at part D. Part D says the square root of 1/18 is equal to blank over 6. So how did we get a 6 down here? Well, this is not under a square root, which means 6 is the square of a number. It's the square of 36. That means that we must have had 36 in the denominator here. How do we change an 18 to a 36? We multiply it by 2. So we must have multiplied our numerator by 2 as well, which means we must have a square root 2 in our numerator to have a 6 in our denominator. Okay, so that was number 5, which is just like number 12 that I assigned for homework. Let's look next at number 6. Number 6 says write each of the following radicals as a quotient without a square root in the denominator. So if you have a square root in your denominator, you have to get it gone somehow. We have the square root of 5/9. Well, that's the same as the square root of 5 divided by the square root of 9. And the square root of 9 is 3. So we can write this as just the square root of 5 divided by 3. Okay, part C. We have the square root of 6/7. Okay, 7 is not a square number. The smallest thing we can multiply by 7 to still make a square number is 7. So I'm going to multiply this by 7 over 7 inside of the square root. And that's going to give me the square root of 42 over 7, because the square root of 7 times 7 is 7. Okay, let's hop over to part D. Part D says the square root of 1/8. So how can I get rid of an 8 in the denominator? I need a square number. The smallest square number that's a multiple of 8 is 16. To get 16, I would need to multiply by 2 over 2, and that will give me the square root of 2 over the square root of 16, because 8 times 2 is 16, and that is the square root of 2 over 4. One more from number 6, that's part F. Part F is the square root of 13/50. If you look at your table of squares on page 563, the smallest square that is a multiple of 50 is 100. So to get 100, I would multiply by 2 over 2. And we will get square root of 26 over square root of 100. The square root of 100 is 10. So we have the square root of 26 over 10. That was number 6, which is just like number 13 that I assigned as homework. Now I skipped number 14 on the homework problem, so we're going to skip number 7 in set 2 and move on to number 8. Number 8 says, what expression should replace the blank in each of the following equations to make it true? Assume that x is greater than 0. Number 8 is just like number 15 that I assigned for homework. So let's look at part A. Part A is the square root of x over 64, and that is equal to the square root of x over blank. Well, we can see that this is going to break into the square root of x over the square root of 64. 64 is a square number. The square root of 64 is 8, so our answer is the square root of x over 8. Part C, we have the square root of 14 over x, and that is equal to blank over x. Well, how did we get rid of the x, the square root over the x? To end up with an x outside of the square root, we had to have had x squared. That means we must have multiplied by x over x inside of this square root. So what we have in our numerator is the square root of 14x. Okay, so let's look now at part D. Okay, so number 8, part D, we have the square root of x to the 16th over 16. The square root of x to the 16th is x to the 8th, because remember, square root is a half power. Half of 16 is 8. And the square root of 16 is 4. So we have x to the 8th over 4. And now we're going to look at part F. Part F has the square root of x plus 1 over 20. And that is equal to the square root of 5x plus 5 over blank. Okay, so we started off with x plus 1, and we ended up with 5 times that much in our numerator. That means we must have multiplied by 5 over 5 inside of our square root. 20 times 5 is 100. The square root of 100 is 10. So this is the square root of 5x plus 5, and it's over 10. So that was number 8. It's just like number 15 that I assigned for homework. Next, we're going to look at problem number 9. Problem 9 says, express each of the following as a quotient without a square root in the denominator. Assume that x is greater than 0. So we're going to look at part A, square root of x over 81. That's the same as the square root of x over the square root of 81. 81 is a square number, so we can just write this as the square root of x over 9. Now we're going to hop down to part C. Part C is the square root of x to the 6th over 25. That's the same as the square root of x to the 6th over the square root of 25. The square root of x to the 6th is x to the 3rd, because remember, square root is like a half power. Half of 6 is 3. And the square root of 25 is 5. Let's move over to part E. We have the square root of x minus 2 all over 3. Okay, we need to get rid of this 3 in the denominator, because 3 is not a square number. So to do that, we need to multiply by 3 over 3. What we're going to end up with is the square root of 3x minus 6, because 3 times x is 3x, 3 times negative 2 is negative 6, over the square root of 9. The square root of 9 is 3, so we have the square root of 3x minus 6 divided by 3. One more part for number 9. Part F, the square root of 1 over 4x cubed. 4 is a square number, but x cubed is not, so we're going to need to multiply this by x over x, and we will end up with the square root of x over 4x to the 4th, which is the square root of x over 2x squared, because the square root of 4 is 2, the square root of x to the 4th is x squared. So that was number 9. It's just like number 16 that I assigned for homework. And there is not time to do number 10 on this video, so I will put that on the part 2 video.